In this video, we're going to learn some of the fundamentals of R, including an introduction to the basic data elements, such as numeric and character elements, how to create variables, how to combine these elements into larger data structures, and how to use R for simple maths operations. So we're going to get started with learning some of the fundamentals in R. And if you're new to programming, then learning these fundamentals will hopefully give you a bit of confidence that programming language isn't as difficult as you might have thought it was. If you're not new to programming, these fundamentals will get you used to some of the quirks in R, which are a little bit different from other programming languages like Python, for example. So we're going to start by talking about basic data elements in R. Now there are multiple data elements in R, but I'm only going to cover three in this fundamentals video. First of all, R has numeric data. So numeric is a data element that represents decimal and integer, i.e. whole numbers. So think of numbers like 2, 3, 4, 5, 6, 7. These are numeric elements in the R environment. Another data element is character. So sometimes we want to have data that represents characters, for example, the names of your participants or the names of certain experimental conditions. So character is a data element that's used for text data. And the final one is logical. So this is a data element that contains elements of true, false, or not available. This is useful for sometimes coding whether data is missing, whether a participant is an outlier in your data, in which case that would be true, or not an outlier, in which case this would be false. Okay, so let's head over into the R environment to start practicing entering some of these different data elements into the console. And if you remember from last video, the console is in your RStudio environment where you see the rightwards facing arrow, and you should see a blinking cursor right next to it. So this is where we can just enter data directly into R. Now with these elemental data types that we're talking about at the moment, nothing really of interest is going to happen at all. It's only when you combine data elements together into more complicated structures that you can start to do more interesting things in R. So the first data element we're going to enter is the numerical data element. And recall this is representing numbers, and this can be whole numbers or it can be decimal numbers. So for example, we can enter the whole number 3 into the console, and if you hit return, all that will happen is that R will repeat back to you what you've just entered. Like I say, nothing really of interest is happening with these simple data elements. But note that we can also enter decimal numbers into here, so we can enter the first 3 digits of pi, for example 3.14. This is also considered to be a numeric data element. The second data element was character, and recall this is representing text data, such as experimental condition names, or indeed the names of your participants. When you enter character data elements into R, you need to include them within speech marks. So for example, if I was to enter my name, Jim, I would put it within these speech marks and hit return, and again, R just returns that back to me in the console window. Character data elements can have spaces within them. It's generally not recommended to do so, but I could, for example, have a valid character data element that says Jim is recording a video, and this is perfectly valid. The final data element we're going to talk about in this fundamentals video is logical, and recall this represents values that are true, false, or not available. Now this is also text input, but we don't include speech marks with these. We just enter in block capitals, for example, true, false, or not available. So now that we've shown you these different data elements, let's have a look at how they can be used in slightly more interesting ways with simple mathematical operations. These numeric data elements can be combined with basic mathematical operators in R, so you can use R just like a calculator. Of course, this is a bit overkill to use R just for the purposes of a calculator, but it does get you used to some of the fundamentals of how R operates. The basic arithmetic operators we're going to cover in today's session is shown in the following table. So we're going to cover briefly addition, subtraction, multiplication, division, exponentiation, which is, for example, raising 2 to the power of 3. And we're also going to talk about the order of operations and how you can control this with the use of brackets or parentheses. So first we can use addition. For example, we can type in 14 plus 32 and hit return. And now R is returning something which is slightly more interesting than we've seen so far. It's the result of some computation that we've done. So in this case, you'll see that it differentiates the output because in my theme that I'm using, it's shown in white, whereas my input is currently shown in purple. So of course you can add any digits that you like, up to any reasonably sized number that you like, and it will operate just like a calculator doing the addition for you. This also works, of course, for subtraction, just using the minus key, and everything else is the same. This also works with multiplication using the star key. So for example, 3 times 6 would be 3 star 6, and returns the output to you in the console window. This is also true for simple division. And here, this is showing how it's returning a decimal point, so 9.5. And of course, just like a calculator, you can combine these in any which way you wish. So you can combine all of those into a single input. When you're combining multiple arithmetic operations in one, just like we saw in that final prompt, you need to be aware of the so-called order of operations. In the United Kingdom, we learn this via the acronym BODMAS. So R will calculate any expression that you put into the console in the following way. First, it will deal with any computations that's within inside some brackets. Then it will deal with orders. So this is exponentiation. For example, it will deal with 2 to the power of 3 next. Then it will move on to work out any division that you have in the input, multiplication, followed by addition, and then subtraction. Failing to take these order of operations into account can lead to unexpected and potentially incorrect outcomes. So it's really important that you keep it in mind. So for example, previously I just entered 3 times 3 plus 4 minus 1 divided by 2. However, we could have expressed this using parentheses. I could have put 3 times 3 within a first set of brackets, followed by the plus, and then a new set of brackets, 4 minus 1, and then divided by 2. So here you'll notice we've got exactly the same numeric input. We've got exactly the same mathematical operators. The only difference between the two is that we've got some brackets in this final input compared to the previous one we had none. And you'll notice that we get a completely different outcome. And that's because in this second outcome, due to the order of operations, R is dealing with what's inside the parentheses before it does everything else. Whereas in the first one, it's just there are no parentheses, so it just does everything in the order of BODMAS. Sometimes it's of use to compare a numerical data element to another numerical data element, and we can do this in R via what's known as logical operators. For example, we can ask whether a certain number is less than another number, less than or equal to another number, the opposite, greater than or equal to another number. We can also test whether two numbers are exactly the same using two equal signs. And we can also test whether a numerical data element is not equal to another numerical data element. Okay, so let's have a go at using some of these logical operators. So for example, we can ask R whether the numerical data element 4 is less than the numerical data element 2. If you hit return, you'll see that R returns false. So this is the logical data element that we encountered earlier in the video. So we're asking the question, is 4 less than 2? And R is returning false. This condition is false. Let's have it returns true. So is 10 greater than 2? Of course, this is the case, and R returns the value true. We can also test whether a numerical data element is less than or equal to a particular value. So we can ask, is 4 less than or equal to the value 5? This is true. And we can also ask, is 4 less than or equal to 4? Now in this case, the equals component is correct, so it will also return true. We can also do the opposite. We can ask whether 4 is greater than or equal to a particular value, 5, in which case this is false. Or is 4 equal or is greater than or equal to 4? And again, this is a match, so it will return true. Sometimes you just want to test whether two numerical data elements are identical. So we can ask, is 6 equals to 6? Note that we use two equal signs for this logical operator. and returns true. We can show that this is working properly because we can ask, is 6 exactly equal to 5? And this returns false. The similar operator to this is to ask whether a numerical data element is not equal to another value. So we could say, is 6 not equal to 6? Of course, they're identical, so this is going to return false. So we've asked, is 6 not equal to the value 6? And R says, no, this is false. We can ask, is 6 not equal to 5? And because these values are different, R will recognize that and return the value true. A fundamental concept in most programming languages is that of variables. A variable allows us to store some information in such a way that we can refer to it using a useful name. So you can think of it as entering some data into a cardboard box, and then we can reference that cardboard box and retrieve the data that's stored within it. So let's say we want to create a variable, and we'll call that variable x. And in that variable, we want to put a numerical data element of the value 4. What we would do in R is we'd first type the name of the variable that we want to create, in this case x, and then we use the assignment. Now this is the leftwards facing arrow followed by a dash. Following that, we would then type what we want to put into that variable. In this case, it's the numerical data element 4. So what this is saying, if read from left to right, is we want to create a variable called x, and we want to put in x the value 4. So we're assigning the value 4 to the variable x. And if we hit return, unlike before where we got some output from the system, in this case R doesn't produce any output at all. However, over on the environment pane, you'll see that we've created a new variable called x, and currently stored in that variable is the value 4. We can retrieve the information in a variable simply by typing the name of that variable and hitting return. In this case, it retrieves the value 4, just as if we'd entered that ourselves. One important aspect of variables in R is that if it contains a numerical data element, we can do arithmetic operations on that variable just as if it was a numerical data point itself. So for example, we could say x plus 2, and because the value 4 is currently stored within x, this is exactly the same as saying 4 plus 2. We can say x times 3. We can do x divided by 2, for example. We can do x to the power of 12, and so on. You can also store character data elements in variables. So I could call this text variable. And in there, I could put, for example, my name. Now, of course, because this is not a numerical data element, I couldn't do, for example, text variable times 2. It's going to return an error because I've got a text element in that variable, so I can't multiply that by a numerical data point. You can also store the results of logical operators in a variable. So I could create a new variable called logical variable, and in there I could store the result of the question, is 3 greater than the value 5? And we see over in our environment window, we've got a new variable that I've called logical variable, and stored in there is the logical data element false, because the result of is 3 greater than 5 is false. As before, we can retrieve what is in that variable just by typing out the variable name. So as you recall, in x we have the value 4. You can overwrite the value contained within a variable just by retyping it as though you're creating it from scratch. So I could do x is 12, and you'll see that now 4 is no longer within that variable. I've now got a new data element within there of the value 12. Just like before, I can now multiply this by whatever I like. I can use it in any other way, just like a numerical data element. When you're creating variables, it's important that you give it a meaningful name. For example, x isn't a particularly meaningful name, whereas I could create a variable called my age. Let's say I'm a little bit younger than I actually am. Let's put 32 in there. You'll see that this is a meaningful variable name. Just by looking at it, I know what's contained within it. It's a number that's going to represent my age. This is much more useful than, for example, typing in x equals 32. That forces you then to remember what x represents, and it can be problematic further down the line when you're returning to your code. You can give your variable pretty much any name that you like. However, it can't start with a number, and also you cannot have spaces within the variable name. So this is not valid. So this would not be a valid variable name. You'll see because we've got spaces in there, it's going to return an error. Also, you can't use numbers, so I couldn't say 1, my age equals 32. Again, because it's got a number in there, that's not a valid variable name, and I will tell you that. It will tell you that there's an error, and you just need to create a variable name just using text only. Because you're now giving your variables meaningful names, sometimes the variable name can be quite long. There's nothing wrong with a long variable name, but in order for ease of readability, there are certain recommendations for how you format your variable name. This doesn't change the way that R functions in any way, it just aids the readability of the work that you're doing, and it's recommended that you follow these conventions to make your variable names interpretable, not only to yourself, but to other readers as well. So for example, let's say I want to create a variable name, and I'm going to call it my very long variable name. There are certain ways you could format this, and hopefully you'll see the difference between the ease of readability between these different naming conventions. In the first example, let's say you don't apply any naming convention to it at all. You just have my very long variable name just all together, and because you can't have spaces, you can't separate the words. This is not very readable, and it's going to be very hard for you and for other people to understand what the variable contains. Another option is to use what's known as camel case. This is where you capitalize the first letter of every word in the variable name. This is better than having no formatting to your variable name, but it still is a little bit tricky to read with ease, especially for very long variable names such as this. The recommendation in the R community, or in the vast majority of the R community, is to use what's known as snake case. So what you do is you use all lowercase, but you separate the words in your variable name with underscores. This provides a little bit of separation between each of the words, and it greatly aids the readability of your variable names. So far we've looked at how R handles single data elements, but single data elements are often of little or no use with any form of statistical analysis. Statistical analysis normally requires you bringing lots of variables, lots of data into the environment at once and combining them in some meaningful way. One way to combine data is to use so-called vectors, which sounds more complicated than it is. A vector is basically just a combination of several data elements into a single object. So if we want to combine data elements into a single vector, what we do is we use this C function. So we'll type C and then we'll open brackets, and then we'll put into those brackets the data elements that we want to put into that vector. So for example, let's represent the shoe sizes of participants in a study. Got no idea why you'd want to do that, but let's say you collect that data for some reason. You can create a variable called shoe sizes. Notice the snake case that we're using here for readability of the variable name. We use the assignment character because we're creating a variable. And then we use this new function, which is C. C stands for combine. We want to combine these data elements into a single object. So we would type C and then open brackets, and then we would type the different data elements into this vector. In this case, we've got 4 participants and they had shoe sizes of 11, 10, 6, and 9. They're all included within the parentheses in the brackets, so they're all being combined together into a single variable which represents our shoe sizes. Notice that we're separating the elements that's going into the vector by commas. To show why vectors are so useful, let's see what you would have to do if you weren't using vectors and you've collected the shoe sizes of 4 members of your family. So for example, I would have to store my shoe size in a new variable called me, and let's say I put in there, that's slightly too big, size 11. And then I can put my brother, so I'll create one called brother, shoe size 10, mum, shoe size 6, dad, shoe size of 9. So we've got data from 4 participants, but at the moment we're only keeping those data in separate variables. So it's like your data is a little bit scattered across a table. Vectors allow you to bring all of that data together into a single object. So we can now create just a single vector, and we're going to call it shoe sizes. We're going to use the assignment character because we're creating this new variable. And remember, we use this C function for combine. So we want to combine, open parentheses, and then we tell R what we want to combine. So we want to combine the values 11, 10, 6, and 9. So now in a single variable, we're containing all of the data for the shoe sizes of the participants in my study. I can retrieve this just like a normal variable as before by typing out its name and hitting return. And you'll see it now returns the elements that I've stored into it. I can pull out individual pieces of information from a vector by using square brackets. So what you do is you type the name of your variable, and then you use square brackets, and then you type in here a number, and the number represents the position of the data point that you want to retrieve. So let's say I want to retrieve the third element of the vector. I would just type in the number 3 in there, hit return, and R pulls out that individual data element and returns it to you at the prompt. Another powerful aspect of vectors is that you can perform arithmetic operations on them if you've got numerical data stored within it, and the mathematical operation will be applied to all elements of the vector at once. So let's say, for example, you wanted to multiply the shoe sizes by 2. Again, I'm not really sure why you'd want to do that, but this is just an example. You can type the name of your variable, then the mathematical operator that you want to select, in this case it's multiplication, times 2, hit return, and you'll see it's now applied that times 2 to each element of my vector. We can also use any other mathematical operation that we've discovered so far. Let's say we want to divide the shoe sizes by 3.4, and again it will return the result of that operation, but it will show the result for each element of your vector all at once. Just like other variables, you can store character data elements in there. So let's say I want to store the names of who those shoe sizes belong to. So let's create a new variable called names. And again, the assignment character there, we want to combine because we've got multiple names that we want to bring together into the same vector. And then we just type in the names of our participants. So it's my name, Jim, brother's name, Ed, mum's name, Carol. Whoops. And then hit return. Just as before, it's storing character values. We can return these by typing the name of the variable and it will return it to you in the console. Just like with single variables containing text, you can't do mathematical operations on this because it contains text data and you can't multiply text data by 2, for example. So it will just return this error to you. You can also store logical data elements within a vector. Let's say we want to store whether each of our participants is retired or not. So we can create a new variable called isRetired. So just asking whether each person is retired or not. And that's the name of our variable. We've then got the assignment character as before. And then we want to combine different logical data elements into one because we've got 4 participants and we want to know whether each one is retired or not. I am not retired, so that would be false. My brother is not retired, so that would be false, but both of my parents are. So this would be true and true. As before, we can retrieve what's in a variable just by typing the variable name, hitting return, and R will return it to you in the console. One really important thing to keep in mind about vectors is that you can only store data within a vector of the same type. So for example, you can only store all numerical data within a vector or all text data within a vector. You cannot mix the two together. So for example, this shows a valid vector because in this case, we've only got numeric data elements being put into it. So this is valid. Whereas this is an invalid vector because we're trying to store some elements that are numeric and some elements that are text. Most data that we're going to analyze, though, is going to be in the format of what's known as a data frame. You can think of data frames just like a spreadsheet, just like in Excel, where it has separate columns and rows are representing different elements of your data. So for example, we can consider the vectors as we have just discussed, but now formatted within a data frame. So we have columns representing the names, shoe sizes, and whether the person is retired or not, and then individual rows storing aspects of data, one row for each participant. Data frames are created in R using the data.frames function. What we do is we pass to the data.frame function the names of the column that we want to give and then the data that we want to go into each column. So starting from the first line, I'm going to go into the RStudio console in a minute and show you typing this in manually. This is just a highlight. We first create a new variable. We want to store this data frame in a variable that we're going to call data. So we give it the name data, the assignment character as we've seen before, but then we use this data.frame function and then an opening of a parentheses. This is telling R that we want to create a data frame, and the opening of the parentheses or the brackets is now telling R that what follows is what we want to go into the data frame. This parenthesis is closed at the end of the function, and what's contained in the middle is what needs to go into this data frame. So we want to create the data frame that we've got on the left here. The first column has the header called names, and you see how we create this here. So we first tell R we want the first column to be called names, and then we want to store in that column the vector of text elements Jim, Ed, Carol, and Steve. As before, we use the combine function, this C function, that tells R we want to combine different data elements into a vector, and that's going to get passed to the names column. The only point of difference here is that we're using the equal symbol and not the assign value. That's because we're not creating a variable here, we're creating a new column, and in R, when you're creating a column, it uses the equals symbol. I did say in the first video that R has some quirks that you need to get used to, and unfortunately this is one of them. It's a little bit of a pain, but after some practice you will get used to it. So this creates a column called names with Jim, Ed, Carol, and Steve in it. We then move on and we say we want to create a second column called shoe sizes that has numeric data elements stored within a vector, again using the combine function. We've got shoe sizes of 11, 10, 6, and 9. And then in the final column we have has retired, which is storing logical information, true or false, whether that person has retired or not. Notice that after we've declared each column, we have a comma, just telling R that we've finished with that column and we're moving on to another one. So let's now create our first data frame in RStudio. To do this, we're going to enter some input to the console as before, but because creation of data frames are slightly longer, data frames has more information in it, we're going to use multiple lines in the command prompt so everything doesn't look particularly cluttered, and I'll show you how to do that in a moment. But first we want to create the data frame and assign it to a variable, and we're going to call the variable myData. As before, you can give it any meaningful variable name that you want, but myData is sufficient for me at the moment. And then I use the assignment character. So I want to assign something to the variable called myData. And what I want to assign to it is a data frame. So it's data.frame. This tells R we're now going to enter some information that needs to be put into the data frame format. We then start the information that we're going to put into it by opening parentheses, and RStudio should complete that with the closing parentheses as well. And in the middle, we're going to type in the data that we want to store in that data frame. But before we do that, we want to create a little bit of space, a little bit of breathing room in the code window so that everything doesn't look particularly cluttered. So I want to use what's known as a line break. And to do this in the command line, for a Mac, you press Shift and then Return. What that does is it provides some space, but we haven't yet triggered the command that we're typing in. So the next thing we want to do is we want to create a new column. We want to give the column a name, and the first column in our data frame is going to be storing the names of the individuals. So we'll just call it names. Then we use the equal sign. Recall we're not using the assignment character because we're not creating a variable, we're creating a column. This is just one of the quirks in R, and we just need to get used to it, unfortunately. What we want to pass into this column though is a vector. So we're going to combine some information. So we use the C function, open brackets, telling R that the following information we want to combine into a single vector. The name stores the names of our participants. So this is character data. So we need to use the speech marks, and then we just type in the names. So the first name is Jim, then Ed, and then Steve. At this point, you'll see we're at the end of the vector that we want to put into the names column. So what we do is we then just put a comma after the parentheses of the vector to say we're finished with that column. We're now going to move on to the next one. To do this though, we want to create a new line break. So don't hit return, you hit shift and return. And then that just gives us a new line break, but still we haven't triggered this command in R just yet. So the next column, we want to store shoe sizes. So we're going to create a column called shoe sizes, and we want it to equal a numeric vector that contains the information shoe size of 11, shoe size of 10, 6, and 9. So they're the shoe sizes of our 4 participants. We go to the end of that vector. We're finished with this column. So we hit comma, telling R we're done with that column. We're now going to move on to the next one. As before, we hit shift and return for a line break, not return. So this gives us a line break, and it still has not triggered this command in R just yet. Our final column is a column just coding for whether each participant in our study has retired yet or not. So now this is a logical vector, and it's going to contain false, false, true, and true. So this means that the first 2 people have not retired and the second 2 people have retired. Now this is all the information that we want to enter into the data frame. So we've now finished our final column of the data frame, so we do not now need to use a comma here. So we finished, so no comma. We now just go to the end of the parentheses of the entire call and then hit return. And if we've done this correctly, we should now see a new variable in our environment window that's got the name that we've just given it, which is my data. And it tells us we have 4 observations of 3 variables. Let's have a look at my data. As before, it's stored in a variable. So you just type the name of the variable, hit return, and then R will give back to you in the output the data frame that you've just stored, consisting of participant names, their shoe sizes, and whether they've retired or not. In this video, we've covered the fundamentals of R, such as the basic data elements, including numerical, character, and logical. We've also shown how to create variables and to bring data together in more complicated structures, such as vectors and data frames, which become of use when we're doing statistical analysis in later videos. I've also created an information worksheet that you can download that summarizes the content of this video in PDF format for your future resources you can return to as you please as you're learning these fundamentals. So I hope you found that video useful. In the next video, we're going to learn about simple functions in R. If you have any questions about the content in this video or previous videos, or if you have suggestions for future videos, please let me know in the comment section below. Cheers.